So for your notes for today, we're going to look at power functions with rational exponents. Before we do anything on this page, I want to refresh your memory at the very top. When you're writing a rational exponent as another form, there's kind of like a method in which you do so. So rational exponents are, for instance, like 1 over 3 or 1 over 4. You can actually write it as a radical. So when you're writing it as a radical, you would have something like x to the m over n power, some numbers. The way that you would rewrite it as a radical is the denominator becomes the index for your radical. You would put the x underneath, and the m, which is your numerator, would become the exponent on m. You should have done this back in Algebra 1. If you didn't do this back in Algebra 1, you definitely did this in Algebra 2. We talked about this. So I'm just mainly saying when you have these in rational exponent form, you can always rewrite them as a radical. So for that whole first row, 1/2, 1/3, 1/4, 1/5, write those as radicals. What would it look like in its radical form? Having x to the 1/2 power is the same thing as having the square root of x. You don't have to put the 2 there because it's understood to be a 2. X to the 1/3 power is the cube root of x. X to the 1/4 power is the 4th root of x. And x to the 1/5 power is 5th root of x. So for all of these questions in a second, you're going to write the rational exponent form and the radical form. So you're going to write both. For right now, though, just for the purposes of time, I'm going to focus just on this first row. So if you look at the first row that actually has all of the numbers filled in, it gives you 4 different graphs and it asks for your observation. As I graph these out, I'm only going to do the first row with you. The rest of this page you're going to do with your partner. In this first row, I'm going to graph each one, and I want you to just take a look at it. What are you observing? What do you notice? What's interesting? What have you found that's different from the person next to you? That's what those observations are for. So for me, you guys not right now, but for me, I'm going to pull up my my computer, and I'm going to pull up the application to actually graph. There we go. So I'm just going to go to Desmos.com. You don't have to do it right now, but you'll just go to Desmos.com and hit the graphing calculator. And from here, I'm going to type in all of the graphs that I have here. So x to the 1/2 power, every single one. I'm going to graph them one at a time so you can sketch the graph on your paper. So for instance, x to the 1/2 power is that. So I'm going to sketch that out. One other thing that I am going to do really quickly is I'm going to zoom in just so that way you can see the increments of 1. So 1, 2, 3, 1, 2, 3, 4, and so on. So I'm putting it in increments of 1. So on my paper as well, I'm going to sketch this out. It does not have to be perfect. I just want to get an idea of what that graph looks like. For the second one, I'm going to graph x to the 1/3 power. That's the blue line. Next, I'm going to graph x to the 1/4 power. Okay, that's the one in green. So the green one is going up. It's a little higher than the cube root function, or cube root, x to the 1/3 power, and it's going over here. So I'm looking at the one in green. And then the last one is x to the 1/5 power. So that one's in purple. So purple is down here. It's going up. And it's right at top, right up here. And it's going to keep going this way. So it has that S shape that we've already seen. So you're just going to sketch those out. And you guys tell me, from these 4 graphs that we've drawn, what do you notice? That's all I want. It's just a couple of obvious things that you notice. Eurydia, give me something that you notice. So which one are you looking at? X to the what power? The 1/2 power, so that's the square root of x. Okay, so that's x to, or 4th root of x, so x to the 1/4 power. That's the one in red and green. What about them?
They're kind of similar.
In what way?
They're both going to the right.
They're both going to the right. What quadrant are both of those in? This is from 8th grade, 7th grade math. Help her out. What quadrants are those in? Not quite. Quadrant 1. These are in quadrant 1. If you don't remember the quadrants, guys, in whatever space you have, write this out. For quadrants, it goes in a counterclockwise motion. So it's going to be quadrants 1, 2, 3, and 4. Those are the quadrants. So somewhere on your paper, not on this graph, obviously, but somewhere on your paper, if you don't know the different quadrants, write this out. So 1, 2, 3, and 4. So you're ready to, let's try that again. You said they were all going to the right, but to the right in what quadrant? First quadrant. There you go. So I'll probably put that in the observation because the more that I write, the messier my handwriting gets. So in this space, you guys write the 1 over 2, 1 over 4 exponents go to the right in quadrant 1. Something like that. What else do you guys notice? Jorge?
Whenever the denominator is even, it looks like it has a parent function of square root.
Okay.
And whenever it's odd, it looks like it's a parent function of cube root.
I like that a lot. So I'll repeat it again if you want to write that down. So for the even, so even are like 2, 4, 6. So for 1/2 and 1/4, for those even denominators, he said that it kind of looks like it has a parent function of square root, which ironically, this is the square root function. And then for the odd denominator, so 3, 5, 7, that's like for 1/3 and 1/5, it looks like it has the cube root parent function. So that's ironically this guy here. Good observation. I like that you use cube root and square root. Those are all I want you guys to do. So when you're making your observations with the person sitting next to you, have the same conversation we're kind of having now. There's a lot of things you can notice. So how I graphed, let me pull up my graph again. How I graphed all of the different graphs at one time for one row, I want you guys to do the same thing. After you're done graphing, literally just hit the X and it will remove the graph for you so you can put in a new one. So right now, I want you to, before you get out your laptop, I want you to add this part in. So if you look at the next row, I know you're like, okay, I can do it on my own. Well, what's your numerators? For the first one, what were all the numerators here? 1. So for this row here, we're going to make all of these numerators 2. For the next row, we're going to make these numerators 3. These numerators will obviously be 4. And then the last row will have numerators of 5. Because we can use whatever numbers we want, but I just want you to see numbers 1 through 5 for your numerators just to see what they'll look like. Before you guys finish, look at 2 over 2. What does 2 over 2 simplify to? So that's x to the first power. What kind of line is x to the first power? It's a linear function, so it's literally going to be a line. You can graph it in your computer in a second when you get a chance to. So for that question, I can't write it in cube root form, or excuse me, radical form. For this question, I can't simplify it. Can I write it in radical form though? Radical. Radical is this part, the outline that I did right up here. How would I write it in radical form? Cube root of x squared. Okay, well, x to the 2/4 power we know can simplify to 1/2, which, hey, we've already talked about that. That's what Jorge was telling us earlier. That's the square root parent function. So I can just rewrite that as the square root of x. And then unfortunately 2 over 5 can't reduce, so I'm just going to write that as the 5th root of x squared. I want you to get in the habit of writing these out because literally on your tests and quizzes, I want you to feel comfortable switching between both. So right now, you can go ahead and open up your laptop, go to desmos.com, click the graphing calculator, and start graphing all of these. You're not just doing it for 2, you're doing it all the way down the page. I'm going to give you guys 10 whole minutes. In that 10 minutes, I want you to graph everything and make observations for every 4 to 8 problems. Are there any questions? All right, desmos.com, hit the graphing calculator and share it with the person next to you. Don't hog the computer. With the protractor or ruler that you have, you can actually create your straight lines for your linear functions if you want. You don't have to, though. All of these just need to be a sketch. All right, 10 minutes. Putting the timer up. Okay, so here's all of the graphs that we have for the ones that you guys were doing. So all of mine are in pink. So I know you can't see each one individually very well, but it should be the same shape or similar shape as to what you have. So Chelsea, give me some observation you have somewhere on this sheet. Okay. When you have an even numerator, it should go in the fourth quadrant. Shouldn't go in the fourth quadrant. Okay, so just take a second and look through it. Some even ones, they should not be in the fourth quadrant. This one technically doesn't count because 2 over 2 reduces to x to the first power, so that one's fine. Okay, so this is even numerator. This is even numerator. These down here, all of these are even numerators. Yeah, looks like none of those are in the fourth quadrant. So if you want to add that to your observations, go ahead. Even though I'm not writing these out, y'all can definitely write them out. Good job, Chelsea. Valerie S. Valerie S. Give me an observation, any observation you notice. And speak loud, because I know I can't hear that well. Okay, so they both of these look like the square root of x, but they're kind of like flipped over the y-axis. Okay, so they both are in what quadrants? Let's do that. What quadrants are they both in? Quadrants 1 and 2. So I'd probably make that note. Quadrants 1 and 2 is where you'll have that 2 over 3 and 2 over 5. I'm going to take that a step further, Valerie, with that. 2 over 3, are those numbers odd or even? Which ones? For the numerator, what type do you have? Even, and then for the denominator? Odd. So when you have odd over even, it looks so far like that's going to be in the first two quadrants. Okay, just with that, with what you said, with even over odd, let me check with these other evens over odd. Even over odd, these are in the first two quadrants. So if you want to make that note as well, you can. Edgar, what's something you guys noticed? Okay, so I love how you said parabola. Which one is the parabola, though? 4 over 2, because that simplifies to x squared, yes. So this guy is definitely your parabola, and you should have that next to it, x squared, and then, especially for this guy, you can also write out the cube root of x to the fourth power. This one, unfortunately, is not a parabola. It was very close, though, but it's not a parabola, but that is a good observation. So if you want to make a note, 4/2 and 4/3, they look very similar to parabolas. They're just not exactly parabolas. Odalis, give me one last observation that you guys made. Give me something. We'll make it easy. On your graphs that you guys made in your, what is this called? In your calculator, let me see if I can move this down. There we go. Looking at these graphs that I have, I know I have a bunch of them graphed, but can you tell me anything from it? Do they all kind of, I don't know, meet at a couple of certain points or meet at a certain point? 1, 1. Okay, so all of these graphs, so all of these in that first quadrant or that first row at the top of y'all's page, 1/2 to 1/5, they all meet at 1, 1. Do they also all meet at the origin? Okay. Is there any other point they all meet at? Well, not all, but some of them meet. What other point do they meet at? -1, -1. That's not for all of them, but that looks like it's for the purple and the blue, so 1/3 and 1/5. So if you want to make that note as well, you might as well. So all of these different graphs that you guys were looking at, it was for a reason. It wasn't just for fun. What I want you guys to do on the back side of the page, all of the observations you guys made, keep them on this page. But on the back side of the page, just flip it over. These are the main things that I want you guys to take from this observation that you guys made. And honestly, some of the observations I'm going to write down, you guys have already told me. So you just need to put it in words. There's 6 observations and a bonus one that we already kind of know. So the first observation that I want you to make note of for future tests and quizzes is when you have your exponent, m over n, when that's greater than 1, I want you to write underneath it or next to it what happens. When your exponent, your rational exponent, is greater than 1, I want you to look back on the graph and tell me what happens. Not at this moment. Not at this moment. There's 6 of them total. So the second thing I want you to look at is when your ratio, your rational exponent, is less than 1. Write out underneath what happens. What do you notice? The third thing is when you have x to the odd over odd exponent. And we kind of already talked about that. Some of y'all's groups literally already discussed this. When you have an exponent that's odd over odd, what happens? Same thing if you had odd over even. I want you to also look at when it is even over odd. And then when x is even over even. These are the main things I want you to look at. So I'll zoom out in a second, but these are all of the 6 things that I want you to take away. I do want to make one last little kind of like a bonus, is when you have x to the first power, because some of these, whether it's even over even or odd over odd, for instance, 2 over 2, 4 over 4, 3 over 3, they reduce to 1. So when you have x to the first power, you guys told me this already, it's a linear function. So when you have graphs like this, don't worry about that x to the first power. So when you're talking about odd over odd, I'm talking about like 3 over 5 or 1 over 3, something like that. So right now I want you guys to do it. Flip back and forth on your page to the graphs that you guys have already done, and I want you to answer these 6 little questions. For each of these situations, what happens? So based on your observations might say exactly what happens. If not, talk about it. I'll give you guys about, we'll say 5 minutes. There's 6 questions. Some of them won't take that long. Some of them we've already talked about. I'll give you 5 minutes. All right, I just want to hear from you guys what stuff you found for each of these. So Fatima, either number 1, 2, 3, 4, 5, or 6, one of those. Tell me what number and what you found from that first page. Okay. Okay, when you said it goes in 2 directions or opens in 2 directions, what quadrants are you looking in? Quadrants 1 and 2. So I'm going to make that little note. So she said that the graph is going to be in quadrants 1 and 2. And if you have something similar to this, it's fine. So the graph is in quadrants 1 and 2. And you said, what about all the y values? The y values are always positive. So when you have an even numerator, so like 2, over an odd denominator like 3, 2 over 5, any of those will give you even numbers. And I don't want to have you guys think, oh, well, they're both going to be going to the right. Because literally, if I look at 4 over 3 on that other page, those are going up. So that's why I want you guys to keep in mind what quadrants they're in, because the direction might change. All right, thank you, Fatima. Jenny, any one of those. So 1, 2, 3, 4, or 6. Which one? So for graph 3, question 3, this is when your graph is in quadrants 1 and quadrant 3. That's that kind of snake shape that you see. So unfortunately, I'm glad that she didn't say that they're both going to be going to the right, because as you go down the page, and I'm actually switch back, as you go back through the page, so far 1 over 3, 1 over 5, not 3 over 3, 3 over 5, all of those were going towards the left and right. But if you scroll down to 5 over 3, that one's not going left and right. So that's what I'm just saying. Focus on what quadrants they're in, because that'll help you with at least which direction they should possibly be going in, what areas they'll be in. Okay, thank you, Jenny. Joseph, you pick number 1, 2, 4, or 6. Number 1, what did you notice when your m over n is greater than 1? The y increases faster than the x. What quadrant is that in? So it almost looks like it's kind of like an exponential function in some places. And it's in quadrant 1. So if it's greater than 1, and I'm going to actually switch the graph to the other part really quick, to the other page. So in the graphs that are bigger than 1, that's going from 3/2 over here to here. So all of these graphs in this area, this bottom part. So if you look at all of them, it looks like this one is true. The y is increasing faster probably than the x is. This one's like a parabola. This one's almost like a parabola. One thing I would definitely put is I'm going to say that it'll definitely go up in the first quadrant. I'll definitely say that. But as far as the y increasing, I don't want to necessarily say that'll be totally true for that graph because it's going down. So I'm going to edit it just a bit. I'm just going to say that the graph is going to go up predominantly in quadrant 1. Can you agree with that? Okay, so I'm just going to edit that just a bit. So the graph is going to go up in quadrant 1. So the graph goes up in quadrant 1. Because technically, if you look at all of those graphs in that section, all of those graphs were going up in quadrant 1. Quadrants 2, 3, and 4, they were doing their own thing, but we were worried about quadrant 1 predominantly. Okay, Jorge, for 2, 4, or 6, which one?
Number 2.
Number 2? Okay, so that's when all of your m over n's are less than 1. So what do you notice? Tell me what it is and we'll worry about the wording. It's going to the right in quadrant 1. I like that. So if I look at all of those are in this top area here. So I think it's about this area. So all of these are going to be going up in quadrant 1. Quadrants 2, 3, and 4 are doing something different, but quadrant 1, I can agree with that. So these are going right in quadrant 1. All right, Jacqueline, numbers 4 or 6, which one? Number 6, what do you notice about number 6? It goes up and to the right in quadrant 1 for all of them that are even over even? I just want to make sure. So for even over even, it goes up and to the right. It technically reduces first, then it goes to the right. Remember, 1 I'm not looking at, so this one we're not looking at. 4 over 2, it goes, this one's technically going up and to the right, or up into quadrant 1. This one was going to the right. So I can't necessarily say that that will be my definite one. But I do notice that they're usually in quadrant 1. If you look at every single even over even one, what do they all do? Because they don't stay the same. They all simplify. So I don't want to necessarily just restrict it to one area, but I will at least say that all of these, at least even over even, will simplify. These will always simplify. And the reason why I'm putting that is because as they simplify, they're going to turn into other functions, which means it's going to change how your graph looks. That's the only reason why I'm not going to stick to more concrete evidence. And then the last one for odd over even, whenever you have those, hopefully you notice that all of your graphs are in quadrant 1. All of those graphs are in quadrant 1. Some of them are going up, some of them are going to the right, but they're all in quadrant 1. So on your tests and quizzes, that front page, I don't want you guys to commit to memory. I just want to ask for attributes. If I give you a exponent like 10 over 2, I want you to be able to tell me based on this what's going to happen, or 10 over 3, or 11 over 9, what's going to happen to your graph. I just want you to be able to describe it. Yes, ma'am. Okay, you're good. So remember, the front page, that's just to help you see the pattern that's going on, because it's truly a pattern. This backside is what I would test you guys on. Questions or concerns? All right.